Hello folks, we come to the part 3 video of the exercise 1.2. Let's continue with the problems. Again they ask us, this is the subpart 5 of question 2, where they are giving us a function f from z to z and they are asking us to show that f of x equal to x cube, whether it is injective or surjective. As we did the previous problem, this is also not going to be injective and this is not going to be surjective, so we are going to give a counter example as to how this happens. So let's check how this can happen. For injectivity, the example will be, it will be injective but it will not be surjective. So that's how we are going to show it. Injectivity, let f of x1 be equal to f of x2 as we do always. So this will come to x1 cube equal to x2 cube. When we take the cube roots, you will get x1 equal to x2. So what happens is, starting with f of x1 equal to f of x2, we are able to reach x1 equal to x2. Therefore f is injective. That is about injectivity. Then we will see surjectivity. Now as we saw the previous problem, this is not a surjective function because there are many unrelated elements in the codomain. So we have to, it's a matter of just finding out some of these elements, some of the elements from the codomain which do not have a pre-image in the domain, as we did before. Probably the example that we used in the previous case, same thing can be used over here. Like you could say that let for we had taken, I suppose, 2. So for 2 belonging to integers, that also codomain, there does not exist any x that is belonging to integers domain such that f of x equal to 2, because it should have come from cube root of 2, as I told you, and cube root of 2 is not there in integers. So that is why this doesn't happen, and therefore this is not surjective. Therefore f is not surjective. Same example as what we saw in the previous case. Okay, next it is a function f of x equal to greatest integer function. It's a very interesting function. We have to check what is whether it is going to be 1 to 1 and on to greatest integer function. Let's check the question. It says that prove that the greatest integer function from R to R given by f of x equal to the greatest integer is neither 1 to 1 or nor on to. So you've got to show that it is neither 1 to 1 nor on to. So let's first understand what is this function, greatest integer function. What is the meaning of that? The meaning of this function, it is from real numbers to real numbers, so it applies throughout the real number line. But for us to get an idea of it, let's just see the positive numbers. First you have numbers from 1 to 2, then 2 to 3, 3 to 4, like that. So between 1 to 2 you have so many numbers, 1.1, 1.01, 1.115, like that. There are so many numbers, 1.7, 1.2, 1.5, 1.5, 1.75, 1.895, like that. So many numbers are there. So then here you have 2.1, 2.85, whatever, then 3.28, then 3.41, like that. So many numbers are there. Now what happens is, by this greatest integer function, all these values will be mapped to the function 1 itself. That is the meaning of greatest integer function. Between 1 and 2, whatever integers are coming, they will be mapped to the function 1. Between 2 and 3, whatever elements come, they will go to the function 2 itself. That's the meaning of greatest integer. So between 2 and 3, whatever is coming, they will all go to the element 2. Then between 2 and 3, whatever is coming, they will all get mapped to 3. Like that. That is what happens. So what happens is, when we observe this, first of all, so many elements are going to one element. That is not allowed for 1 to 1. And another thing is, only the integer elements are related. The non-integer elements, like this is real, we are having the function from real to real. There are so many other elements which has got no pre-image, right? Because all these elements are linked only to the integer part. So the non-integer elements which are there in the codomain, they don't have a pre-image. So that is how we are going to show that it's not surjective. So let's check. In first they ask us injectivity. Yeah, they are asking us 1 to 1. So let's check for 1 to 1. here we could see from here f of 1.1 is 1, f of 1.7 is also 1. So two pre-images having one same image is not allowed. So therefore 1.1 and 1.7 has the same image 1. Therefore f is not 1 to 1. We don't allow that. Okay, for 1 to 1 we don't allow that. Then we'll show for onto why it is not onto. For anything, right, you have so many numbers over here. For 1.2 belonging to R codomain, there does not exist x belonging to R domain such that f of x is 1.2. Every element is going to go only to an integer. It will never go to a number like this. That's not how the function is defined, right? So as a result, we have so many elements lying over here which are not related. That is why it becomes not onto. It's not onto, right? That's about this. After that, we quickly come to the next function, which is modulus function. Modulus function is also of the identical kind, where they are saying we have got to show the same thing, like the modulus function is neither 1 to 1 nor onto. Same problem exists over here. We know that modulus function, the negative and positive goes to the negative 4, negative, positive 4 and negative 4, they both are mapped to 4. So like that, we'll have many elements mapped like that, and therefore we will be it will create a trouble and we'll not get it as 1 to 1 and onto. So let's understand this function. F is defined from where to where? It's from R to R. Yeah, it's from R to R. So broadly, let's take to start with. This is just for us to understand the function. Minus 3 and 3, they both will go to 3. You know now, f of minus 3, modulus means the positive value. Then f of minus 2 and 2, they both will go to 2. F of minus 1 and 1, both will go to 1. F of 0 will go to 0. So these are just some. The entire real number line is there. So many such. This is just for us to understand. We know that modulus means any value that you're taking for x. When we apply the function on it, the final answer that you're going to get, it's going to be a positive value. So what happens is two values having, or two pre-images having the same image. That is a problem. So it's not onto, it's not 1 to 1. And why it is not onto? Because you've got only positive elements related over here. If you take any negative value, minus 1, it doesn't have a pre-image, right? Because every number is converted into a positive number by the modulus function. And therefore the negative elements, they're just lying like that. They don't have a pre-image. And that is why it's not onto. Okay, so that's how we're going to proceed. Let's check for 1 to 1. Yeah, f of 1 is 1. F of minus 1 is modulus of minus 1, which is also 1. Therefore 1 comma minus 1 has the same image 1. That's not allowed. So f is not 1 to 1. Then check for onto. For minus 1 belonging to R codomain, okay, there does not exist x belonging to R domain such that f of x is minus 1, right? And that is why f is not onto. Okay, so that's about it, and that is about this part of our video where we have taken up these functions and we've shown why it is not 1 to 1 and onto. With more problems, we are coming in the next part. Thank you.